Everyone, we are group 5. Today we will summarize the kinematic constraint of model robots. To analyze this constraint, we first must establish the fundamental assumption for our model. These simplifications are crucial for defining the system behavior. First, we assume the wheel operates in a vertical plane. Second, there is only one single contact point between the wheel and the plane. Third, and most importantly, we assume pure rolling. This means the wheel rolls without any slipping. This directing implies our force assumption. The velocity at the contact point is zero. And finally, for this model, we also assume no friction. This assumption form basis for deriving the constraint equation. Thank you.
Continuing with the discussion about kinematic constraint, we will now focus on fixed standard wheel and stilted standard wheel. These two types of wheels share two important constraints. First, the rolling constraint, which ensures that the forward velocity is only caused by wheel's spin. And second, we have a sliding constraint, which forbids movement perpendicular to the wheel's plane. This fixed standard wheel is the simplest type and with a constant orientation beta. Stilted standard wheel, in the other hand, adds a second degree of freedom, rotation around a stilted axis that passes through the center of the wheel and ground contact point. In this case, beta is no longer a constant, and these types of wheel get more maneuverability.
Right now, I am going to talk about the caster wheel. In this case, we have a new parameter d and beta in the sliding constraint that, for example, d is a geometric parameter that is the distance between the chassis and the wheel. And beta is the angle in which this wheel rotate. If this angle is 90, the robot will not be able to rotate because this wheel is going to be like this and the other wheels that are behind are going to stay like this. Now we have the Swedish wheel. This Swedish wheel have the difference that, for example, this this will be the motion will be able because of the roller axis. And now we have the spherical wheel that is have that this sliding constraint help us because it will allow us to slide if we require that. So thank you very much for hearing us. Good night.